Hello and welcome to my channel. In this video we are going to understand about momentum, its types, its relation with impulse, its units and its examples. So as you know the basic terms of the physics like velocity and acceleration, momentum is also a basic term that actually tells us that what is the quantity of motion in an object. So if an object is moving, so definitely it has some velocity v, and definitely it will also have some momentum that actually indicates that how much that object is actually moving. Okay, so it is also defined like a mass in the motion, mean how much mass of that body is involved in the motion that body is doing. The next thing that we will understand about it is that usually the momentum is mixed with the one type that is actually linear momentum. So basically momentum is only defined as the quantity of motion of any moving object, but the linear momentum is some related to the type of the motion that the object will do. So that's a type when momentum is the basic term. Here is the unit, that is kilogram meter per second. Now how it is derived, that will be definitely from its formula that we will discuss a little later. There are some examples that a semi truck that is filled with some load whatever, that have definitely some mass, and now if it is moving then it has velocity v. So any object that has velocity v mean it is moving, then that must have some momentum. Okay, and if the mass or the velocity of the object is higher, then it will have more momentum. Okay, so here are the two types of the momentum, that are linear momentum and angular momentum. So linear momentum means that when an object will be moving in a linear way, mean in a straight line, you may say, so then the momentum that body will possess will be termed as linear momentum, and that is given by p is equal to mv. That is the actual term that is mixed with the momentum. Okay, so m is the mass and v is the velocity of the object, and definitely v is a vector, so clearly p will also be a vector. So from here we find out the unit, that is kilogram meter per second. So kilogram is the unit of mass and meter per second is the unit of velocity. So in this way this unit is derived. Now we see that what is the relationship between the linear momentum and the Newton's second law. So as you know that Newton's second law states that if any body is subjected to some force, external force, then that force produces acceleration in that body. Okay, so that was actually given by F is equal to ma, and we know that acceleration is defined as the rate of change of velocity, definitely with respect to the time. Now if we substitute this value of a in this above equation, that is F is equal to ma, then we will get F is equal to m delta v by delta t. Okay, and as I already mentioned over here that p is equal to mv, so here m delta v will be replaced by delta p. Delta p means there will be a change in momentum since velocity is being changed. So it is concluded from this relation that the rate of change of momentum is equal to the applied force on that object, or the force that is driving that object to move. Now the next relation that we are going to understand over here is impulse and momentum. What is impulse? Impulse is basically defined as the product of force and time. Since sometimes the applied force is very small, so we usually multiply it with time, then that becomes a new factor and it helps us in calculation. So F multiplied by delta t is equal to p. Now from here it is derived from here. if you take this delta t to the other side, then definitely delta p will remain on this side and delta t will be multiplied by f. That actually becomes impulse. So impulse is equal to change in momentum. Make sure that delta p is indicating change in momentum, but delta p over delta t is indicating the rate of change of momentum with respect to time. Okay, the second type of the momentum is the angular momentum. So when any object will be moving in some circular path, then that will have some angular momentum. Again, momentum is the same thing, but just the type of motion is changing the term completely, like linear or angular, whatever we are discussing. So it is indicated by L, capital L. Capital L is also a vector over here because it is defined as product of mass, velocity and distance r. So distance r is a little complicated, that I will just tell you a little later. Firstly, let me tell you that as v is the vector, so definitely L is also. P was equal to mv as we already studied, so P is equal to mv. So if we substitute this value in the above relation, then we get L is equal to PR simply. Now what is R actually? Let me show you from this diagram over here. You see the object is displaced from the origin at some distance r. So the axis that is passing through the origin is actually the axis of rotation, and the object that is far away from it is actually that object actually, right? So L is given by the cross product of the distance and the linear momentum. So that is clear from here, right? Now moving back to our topic, that was L is equal to m into v cross r, as I just show you in that diagram. And here definitely that's the cross product. So there is the angle between v and r, the plane that is being made by r and v makes a surface or a plane. So that will be definitely opened as sine theta, as the cross product usually done. So L is equal to mvr sine theta. So as indicated already, so L will be equal to r cross p. So omega is the angular velocity, as just you saw from on the diagram. So in the case of a rigid body, the angular momentum is defined as the product of the moment of inertia and the angular velocity omega. So L is equal to I omega. This is just in the case when you have a rigid body that is moving with velocity. And now we see that the law of conservation of momentum. So like the other laws, law of conservation of energy or mass, so similarly the law of conservation of momentum also holds in the real life. So if an object that is moving collides with some object, so the momentum of that object before collision and the total momentum after collision will be equal completely. Let's understand it. Here you consider a case of the bomb explosion. So consider that the mass of the bomb was initially m and its initial velocity was v. That is definitely zero because it is just placed over some place. So when it explodes, then definitely it will move, its fragments will move far away, then it will be divided into the masses definitely, so that have mass m1 m2 etc, and definitely they will have different velocities that are v1 and v2. So now the sum of all those momentum and the momentum of the initial bomb, mean in actual form, will be same, will be equal. So the total momentum in this overall system will remain equal to zero or will remain as constant, but before the event or after the event, the momentum will remain same. Thank you very much.